The universe is intelligible because it is relatively orderly. It's relatively orderly in the sense that there's a certain self-expressiveness of the things in this universe that are observable, directly or indirectly. Yet that self-expressiveness happens precisely because things have natures or essences, and in essence, ontologically or metaphysically speaking, limits the existence of these things we are observing to be the kind of things they are. Also note that we have access to the world around us. Our minds are capable of understanding many things, at least to some extent. Howdy, I'm the Amateur Logician from amateurlogician.com. Today, we're going to be previewing logic and science. We'll reference Sir Isaac Newton and an obscure but important logician named Peter Coffey. We'll consider the question like we did in previous videos, what makes a good inductive argument? We'll consider the simplicity criterion and the coherence criterion. Plus, we'll glance at the scientific method and more. Now, I claim that an optimistic view of the universe recognizes and affirms that we can know things. It recognizes the power of physics, chemistry, biology, astronomy, and so forth. This more optimistic view, moreover, recognizes that ideas are means by which we understand. We're not locked into our own subjectivity or our own subjective ideas. Technically speaking, ideas are formal signs. And in a previous video, we talked about the logic of signs, including formal signs. Additionally, an underlying topic you'll find in traditional logic books deals with the uniformity of nature. The same physical causes acting under similar conditions produce similar results. And you can link this up to the thinking of Sir Isaac Newton. For example, if you look at the Principii, the second rule that Newton lists, or mentions, or talks about, is as follows. Therefore, to the same natural effects, we must, as far as possible, assign the same causes. The same cause produces the same effect. Gravity, he says, works the same in Europe and in America, or wherever. But in fact, rule number 2 nicely follows from rule number 1, or goes with it. Rule number 1 is as follows. We are to omit no more causes of natural things than such as are both true and sufficient to explain their appearances. In commenting on this, Newton says that nature does nothing in vain. And this really upholds a traditional Aristotelian scholastic principle. Nature is, in this sense, simple or economical. Also, things have reasons for being. Effects have causes. And you can see that Rule 2 nicely follows Rule 1 because it goes against nature to suppose two different physical forces will produce identically the same thing. There's a uniformity of nature, in other words. But moreover, as we do this, we also have PSR. That is the principle of sufficient reason. Whatever exists has an adequate explanation of its existence and the attributes it has. Common sense has it, it seems to me, that there's an explanation for things that don't explain themselves. In fact, inference to the best explanation seems to presuppose PSR. But also note that implicit in Newton's rules really is a simplicity criterion. Ceteris paribus. In other words, other things being equal, the simpler theory is better. As the simpler theory has a higher degree of probability of being true, whereas something more complex, so to speak, carries more baggage that can go wrong. But also, we see, at least implicitly, there's also the coherence criterion. Other things being equal, the theory that harmonizes with the other theories is better. We should prefer a theory that harmonizes with well-established beliefs. That is, it shouldn't contradict what we already know is true. So an argument might be like this. Theory X explains all of the data. It is simpler than theory Y, and it better harmonizes with other known theories than Y. Ergo, theory X is more likely to be true. Moreover, consider Rule 3 from Sir Isaac Newton. The qualities of bodies which admit neither intention nor remission of degree and which are found to belong to all bodies whatsoever. We can induce, Newton says, the universality of gravity Further, we can infer the laws of motion about all bodies. When it comes to thinking about the world around us, experience must ground us. Truth is not determined by us, but by reality itself. And induction in the so-called hard sciences must be incorporated into a sound philosophy. Now, the scientific method, which all of us have learned about in school, roughly speaking, is something like this. We're to observe and question. Observe and question a phenomena. A phenomenon has been observed, questions are raised about it. For example, what is causing something? To what extent is something reacting to something else? Offer an answer with a hypothesis. Give an educated guess that is testable with some experiment. And note, any hypothesis should be relevant, logically compatible with other things known, give clear predictions, and generally have simplicity. And then we should predict the hypothesis consequences. Make predictions about what is entailed by the hypothesis. Implement experiment. Run an experiment that tests the hypothesis, or run calculations to test the hypothesis. Is the hypothesis confirmed or not? And formulate the results. Put together the hypothesis, the predicted consequences, and the experimental findings. Now, to be sure, as I said, this is a very tentative outline. A hypothesis might start the process instead. It might not just be observing something and then formulating questions and hypotheses. But this general spirit is behind the scientific method. But through this, Peter Coffey, in his book The Science of Logic, Volume 2, offers some advice. And for example, the philosopher D.Q. McInerney summarizes and references this work. Coffey tells us to focus. Don't take on too much at once. Slow down. Investigate carefully. Have the right expectations. You can't get greater certainty than the subject admits. Peter Coffey also writes about experimentation, which are observations under controlled conditions. And when it comes to forming hypotheses, he offers the following advice. These hypotheses should be based on observations, be self-consistent. They shouldn't contradict known truths. But perhaps even more interestingly, he says that they should be based on an analogy with other known cause/effect relations or other theories. They should be in harmony with what we know from other things in that sense. But also they should be verifiable, and we should narrow down things to the best explanation. This is the type of discussion and investigation that Peter Coffey has in his book, The Science of Logic. Now, I am the Amateur Logician from amateurlogician.com. Of course, we're just skimming some basics here. There's always much more to investigate and learn. But if you enjoy this type of material, please consider subscribing to this YouTube channel. Please consider giving this video a like. I would really much appreciate it. Thanks for your viewership, and be well.